active ba yan? May quiz kasi ako sa DE, kailangan ko ng
Magkano na akong mahal? Boss, may good item ka ba dyan?
Siyempre, meron tayo niya. Meron tayo.
Gawa mo nga ako, kailangan gumawa mo. May mga bibenta tayo.
Sige lang. Lapit mo lang sa akin.
Bad boys, what you gonna do? Or what you gonna do when they come for you? Bad boys, what you gonna do? Or what you gonna do when they come for you?
Saan mo na? Isa naman sa labas ka po.
sigurado ko dito.
Oo, sure.
One day later.
Para mas lalo sumama pakiramdam ko doon. Ano ba naman yan? Sakit.
Why didn't the drug work? Why are there side effects? Let's analyze it using differential equations. In pharmacology, for a drug to work, it must react properly inside the body. This reaction should be spontaneous, meaning it happens naturally under normal conditions. However, in this case, the drug was non-spontaneous, meaning it didn't activate, leading to harmful side effects instead. This is the equation for drug breakdown in the body. Here, C is the drug concentration, K is the reaction rate, and T is time. Let's assume that Kyla took 500 milligrams of the fake drug. But because it's ineffective, its reaction rate is very slow, at K is equal to 0.01 per minute. The concentration follows then this formula. C of T is equal to 500E raised to negative 0.01 T. Now, let's see how much of the drug remains after 1 hour or 60 minutes. The computation shows that even though 274.4 milligrams of the drug remains in the body, it doesn't work because it failed to react properly. The therapeutic threshold, or the minimum amount needed for it to be effective, is 30 milligrams. But in this case, the drug isn't working at all. So, the medicine stayed in Kyla's body, but it did nothing. This equation represents the buildup of harmful substances due to impurities in the drug. In this equation, S is the amount of harmful chemicals, while R is still the growth rate. The impurity concentration then follows this formula. Let's say the impurities start at 0.5 milligrams, and we want to find out when they reach a dangerous level of 10 milligrams. Solving for the time gives you 60 minutes. This means that after 60 minutes, the side effects reach dangerous levels. Even though the drug didn't work, the body suffered from the accumulated toxins. So, the drug concentration decreased but didn't work. Meanwhile, the harmful substances increased exponentially and caused side effects.
In our skit, two friends, a scientist and a con artist, deceive a desperate customer who needs immediate relief for her upcoming exams, highlighting the perils of fake medications. When the scientist produces a medication that is tainted with contaminants, the reaction becomes non-spontaneous and ineffective, which ultimately results in negative side effects rather than healing. This situation highlights the dangers of unreliable medications and increases knowledge of the repercussions of taking counterfeit medication. The rise of counterfeit medications poses a serious threat to public health, often leading to ineffective treatment and harmful side effects. In this skit, a desperate customer falls victim to deception when a scientist and a con artist offer a contaminated drug, rendering the reaction non-spontaneous and ultimately ineffective. Instead of providing relief, the tainted medication causes unintended consequences, emphasizing the dangers of unreliable pharmaceuticals. This scenario raises awareness of the risks associated with counterfeit drugs and the importance of ensuring medication safety. So, in conclusion, this skit gives insightful information about the risk of fake medications and how they affect people who need urgent care. By using differential equation ideas like the Gibbs free energy and reaction spontaneity, we were able to draw attention to the dangers of ingesting tainted medications as well as the scientific foundation for drug efficacy. The depiction of dishonesty in the sale of counterfeit medications also highlighted how crucial it is to exercise caution while buying medications from reputable vendors. In addition to broadening our knowledge of practical applications of mathematics and chemistry, this experience reaffirmed the need of moral responsibility in pharmaceutical and medical procedures.